Hi, in this video I will show you how to create the basic workflow of prover and verifier using Risc Zero zkVM. So first of all, what are the requirements here? With Risc Zero, the entry level is relatively low, so almost anyone who has some kind of experience with Rust and some coding experience can actually start writing own applications based on Risc Zero zkVM. The only things that you will need, except of course some coding and Rust experience, will be also having Rust installed on your local machine, having some kind of coding editor, as well as Risc Zero cargo crate to create a new project instance. Before we start, let's have a quick recap of what is zero knowledge and why would we even need this kind of technology. So with zero knowledge, we can hide some inputs and prove it to the other side that we know how to get the given output. For example, let's think about some kind of real use case. Let's say that you are on the airport and you want to prove to the officer that you have the visa, but without showing the passport itself, or let's say its contents. As maybe you want to secure your, let's say, sensitive data. In theory, with zero knowledge proofs, we could create a special program that if you input your passport data just on your side without revealing these inputs to the other side, you can generate a proof and show it to the officer, so then he can trust you that you really have the visa and it is the correct passport, let's say. A few words about Risc Zero and how it works. Actually, it is probably one of the most user-friendly and one of the easiest way to start with zero knowledge. Let's look at how it works first of all. So first of all, we have this host environment. Let's say it can be our local machine. And on this host, we will actually create and compile the program and put it inside of the guest virtual machine. And guest virtual machine is actually RISC-V based virtual machine that can execute some kind of code. So in our case, we will create the code that will give the output of two factorials. Let's say the factorial of, let's say, two inputs. We have two numbers, and we will get the output of those two, let's say, multiplication of those two numbers. So without showing the other side what are those two inputs, we can prove that we know what kind of inputs to put inside of this program to get the given output. So still, having this application on our local computer, we will create this code, create the new instance of the virtual machine. We will also provide it with those two input numbers, execute the code still inside of our computer, inside of the virtual machine. This virtual machine will commit the results to the receipt, and this receipt will be returned out of this virtual machine back to the host. It's still on our, let's say, local computer, and with this receipt we can prove it to the other side that we know how to get the given output without revealing the inputs. Later on, we can just get this input receipt and serialize it and send it to someone else so that other side can verify that we are really the, let's say, we really know what the inputs are. Let's have a quick look on what is inside of the receipt. In receipt, we have a journal, also the output of our calculation, as well as the specialty, which is cryptographic zero knowledge proof. And this actually is also a zk-STARK, which stands for zero knowledge, scalable, transparent argument of knowledge. But don't worry, you don't have to understand what are exactly those zk-STARKs, zk-SNARKs, and very complicated math behind it, as Risc Zero actually abstracts a lot of this heavy math and difficult theory from you. With that, we can start creating our project. First of all, like I mentioned before, you will have to install the crate cargo Risc Zero on your local machine. Once you have it, you can open the editor, and once you are in a desired, let's say, folder where you want to create the new instance of your project, you can just execute a command cargo Risc Zero new, let's call it multiply, as it's also one of the tutorial projects. As you can see, after executing this command, we will have a template here, and let's have a look what's inside. Also, let's go into this folder here. The structure is very simple. Actually, we have this host program, which is not the virtual machine yet. As you can see, we have something already here, but we will have to modify it. As well, that is the methods folder. So inside of the methods folder, actually we have our, as you can see, guest code, and this guest code will be compiled and executed inside of this virtual machine. First of all, let's start from this method. So the program that we will run inside of the virtual machine. As you can see, by default, it's named as a method underscore name, and in cargo also the name is just method guest. We can just change the name to multiply and change the name of this file as well to inside of this file we have this main function. This will be the function that will be executed inside of the virtual machine, and now we can add our code here. What we will want to do is just to create the product of two inputs. So let's say it will be A and B. We will get those two variables from the outside, from the host. When we will be creating this new virtual machine instance, we can just pass, or let's say commit, those two variables, so then they can be read from the environment. As you can see, we don't have this environment defined yet. We can define it, for example, here. First of all, we can also create the check, just like it's in the official tutorial as well. So just to verify that we don't have the non-trivial factors. Otherwise, we want to just process with the executing the function. We will also calculate this product in this way. Also, have this kind of, let's say, error handling in case of the overflow. Once the product is correctly calculated, we can commit the output of this function back to the host machine, let's say outside of the virtual machine, and save it inside of the receipt. So in this case, you will now commit it to the environment, and with that, that's all we need on our virtual machine side. Now we can go back to the host folder. You can see currently we have the main file under the src folder. However, we want to divide them into the prover and verifier. Therefore, we can create a new folder called bin. We can move it here and rename it to proof. Let's create a new file called verify.rs. So we have this both prover and verifier. Now we will need the logic for the prover. You can see here we are using the local crate, which is called methods, and the methods are here. And we have this method name elf as a method name id. So method name elf is actually the binary file of the compiled code that we have written for our virtual machine, and method name is a special ID number of, let's say, this binary code. Someone could have cheated us and, let's say, modify the program on their side and generate the program that generates the desired output, but with different inputs. That's why we need this additional layer of the security to check whether we have, let's say, whether the program was run on the correct version of the program or not. As you can see, now I have the error here already because I've changed the name. So in this case, we should rename it to multiply health. And as you can see, we have this prover here. Of course, this is also wrong, so we have to use the binary that we've created. Before we even define the new prover instance, which will be our virtual machine instance, we can define two inputs that we want to feed the virtual machine with. Those are our secret inputs. Below, we are creating the new instance of the virtual machine, the prover, with the given binary file that we've created inside of the methods folder. At this point, once we have our secret inputs defined here, and we have the prover instance also created, before we run it actually, we can feed it with the inputs. So what we can do is just use the prover.add input. As you can see, even the coding editor helps us. And here we will need to convert it to a vector. So as you can see, I was just extracting those values inside of the guest code in an order. So firstly, I was just getting the first value, which was A, and then B. That's why we have to convert it to vector. However, we don't have the function. We can import it actually. With that, we already gave the first input to our prover instance. We can just copy paste it actually, as it will be the same. The only thing we'll have to change here will be the variable b, and we are almost ready to run the new instance. So the receipt will be saved inside of this variable. So as you can see, once we've created the prover instance, we also gave it the 2 inputs, and we execute the run function on the prover instance, and that should create the receipt and save it inside of this variable. We have this helpful comment that tells us that at this point, after getting the receipt, we can serialize it and transmit it somewhere else, whatever. Let's create another variable. Let's call it, for example, result. We will want to retrieve this result from the receipt itself. So for that, we will need fromSlide method. And as you can see, already it has been imported automatically by my editor. However, you may need to change it manually in case. So it should look like this input. So we will have both two methods, the toVector and fromSlice. And our slice will be the receipt, actually the reference to the receipt. And also we will have the result here, so we can just unwrap it if everything goes as we expected, let's say, as we planned. If there is no error, we should get the result here. We can also print it here to our terminal and see the output. So for example, we can just use the native print line macro. With this, we can be sure that we have the result that we expected. Later on, can run the verification. As you can see at the end, we have the verification, which is optional, because like I said, actually this part here shouldn't happen on our part, because otherwise there is no point of this whole workflow, as of course we know the input and we can just do it just for ourselves, just to check that the code runs correctly. So let's leave it for a while, but shortly after that we will create another file. Actually we have the file, but another code where we will only verify let's say the deserialized serialized receipt, and then verify is it correct or not. However, just for the sake of, let's say, kind of a simple testing, let's add it here. Should of course change it to. So with that, we should be ready to run our code. What we can do is cargo run release bin and proof. Alright, so when you run it for the first time, it can take a while, as it has to download all of the libraries and compile them. However, once it's done, as you can see here, I see this message here. I know the factors of 392 and I can prove it. So it means that our program worked, nothing crashed, so most probably our receipt is generated correctly. With that, we can now modify our code a bit, because still, even though we have the full workflow, it doesn't mean much, because we can just create the program on ourselves and verify it to ourselves. So it doesn't make much sense. So this is the basic command to execute, let's say, Rust programs. However, we have this bin, so we have this inside of the bin folder, and which file, so proof. So we were just aiming the proof file. Before we move on to verify, we have to find a way how to transmit, let's say, this receipt that we have here in this variable. What we can do, actually we can just remove this, as we won't need it anymore here, and serialize it and then save it to file. This, we will actually need another variable called serialized. I am personally using this library called beancode. I also have seen it that it's also used in the official, let's say, projects built by Risc Zero on their GitHub repository. As you can see currently, we have this error here, as we don't have beancode inside of the dependencies. So what we can do also here is just import it here. So bin code, for example, I'm using the version 1.3. Maybe there is different version at the moment of you watching this video. However, at least for me, 1.3 worked fine. Now everything should be fine. We have the serialized file here. And what we can do with that, once we have this serialized file, we can save it to the file. Let's say file, and inside of this we can just create a match, verify that everything went correctly, and we can use the standard library file system and write. So as you can see here, we need the path as well the file. So in our case, we can just create something like this, name it receipt.bin as its binary file, and the content will be the serialized. As you can see, it's a vector, and inside of this match we can just add two conditions. So okay, if everything goes correctly, we can just print the message to the user. Now everything should be correct right now. Let's run this code once again. As you can see, now we are not using the ID anymore because we will actually need the ID inside of the verifier. So we can also remove it. We can remove the curly brackets here as well. Code for the prover should look like as follows. And let's execute this function once again. Since we have all of the libraries already compiled and on our local machine, it shouldn't take much, just the bin code was missing. Again, we got this message as well as the receipt saved and serialized as receipt.bin. As you can see, here is the binary file. I can see that already has been created. So the last part of, let's say, our workflow is just creating this verify rs file. So first of all, we will need this ID of this binary code, let's say, that we executed in the guest virtual machine. So we will need this multiply ID. Just like inside of the proof, we use the multiply elf, this binary file here to create this prover instance. Here we will need just the ID. Verify that the given receipt was created with exactly same binary file. We will also use Risc zkVM and receipt. So with those two imports, we should be fine. We can just create another main function here. What we will need, first of all, we need the receipt with this string, with, let's say, this location of the receipt. We can just retrieve the file. We will use again standard library file system. It will be read, and the path, of course, is this. So receipt, let's change it, receipt path actually will be more correct. With this, we should get the receipt file inside of this variable. So we already serialized it and saved it to the file here from the proof rs file, and now we are just reading it back here to this variable. And also, since we have it, let's say, in the instance of our verify code, we also need to deserialize it. That's why we can just define another variable called receipt. We will also want to define what kind of type is it. That's why we need this receipt here. So now it will deserialize as this type of the file. So to the receipt, have the typo here. Okay, now it's fine. So now we have the file both read from the system as well as deserialized. And the last thing we can do here, and the last thing that we will do here is just the verification. And again, match, we will just execute receipt verify. We will pass the ID of our file, so to multiply ID. Okay, all right, we are almost done with our project. Let's just verify that it works. And at this point, we can just execute another file. So in this case, it will be verify. As you can see, we have already this receipt saved here. So instead of proof, we can just execute verify file. Yes, and as you can see, everything works correctly. So we have this message, proof is valid. So that's all. Let's just summarize what we have done here. So inside of this host folder, we have two methods. Let's say this proof and verify. Inside of the proof, we are just creating a new prover instance where we pass those variables. We create the receipt, we serialize it, and then we save it to the file. In our case, it's here. Then inside of the verifier, we have this, we read this file from the file system and deserialize it as the receipt, and then we can verify is the file, let's say the receipt, correct or not. Keep in mind that two things should be should also always match, and this is also of course the file as well. This multiply ID, let's say in our case multiply, but of course it can be any kind of method. So the method that you used ID should be the same, otherwise you will get an error. Also keep in mind that this is still work in progress project, even the Risc Zero, and sometimes there are some issues with Rust and Risc Zero, so you can get the different ID if you want to pass it to different instance of the code on the different site. However, if everything goes correct and you have the correct multiply ID as well as this file, even by sending this file to someone else, the other site should be able to verify have you provided it with the correct input or not. So that's all for this video. Thank you for attention. If you have any feedback, comments, please leave them in below this video, and let's hope to see you again in another video about zero knowledge proof and Rust. Thank you for attention.